so.
Hi, Emily.
Hi.
Thanks for coming.
Yeah.
Okay, we'll go ahead and get started. There might be a few stragglers, but
All right,
you're a pro. You can handle
I
that.
can handle the strike.
Yeah. All right. So it's my pleasure today to introduce our Bair Ranch Foundation seminar speaker, Dr. Matt Reeves. Matt is a research ecologist at the U.S. Forest Service Rocky Mountain Research Station in Missoula. He specializes in building and applying remote sensing tools to model ecosystem dynamics in rangelands. And he uses these skills not only to produce highly impactful science, his work has been cited more than 4,000 times, all right, but also to inform land use planning on Forest Service lands. And he's gonna, I think today, talk about the integration of the tools that he develops and how it's used to inform national forest planning. Is that right?
Close enough.
All right, good enough. Thanks, Matt, for joining us today.
Yeah, there's just one lie in there. I have no idea how impactful anything is anymore, but after COVID, everything kind of went out the door. But thank you all for joining me. I'm glad to be here. I've got to know a few people. Some people I have known from previous stuff, but a little bit about background beyond what Lance had mentioned. So I graduated with my PhD in 2005 from the U of M, figuring, what am I going to do next? Like a lot of you will be facing. I went to work at the Rocky Mountain Research Station at the Missoula Fire Sciences Laboratory. There I was the landfire fuels team leader. You can Google landfire.gov. If you're interested, you'll find they've come a long way since then. It's about a $100 million program. So there's some good information there for anyone doing landscape scale work. Lots of data and different things there that you might want to poke at. After that 4-year term, I was invited to become the lead for Rangelands in the Renewable Resources Planning Act. An obscure piece of legislation from 1974 requires the Forest Service to evaluate the status and trends of U.S. rangelands, but also make projections about key resources. There's other resources there too, water and fish and wildlife and timber. But oddly, the Forest Service was the sole agency responsible for doing that work. So that occupies a good bit of my time, along with some of the stuff I'm going to share with you today. Recently in my career, I've been pivoting more towards working with the National Forest System at different levels, usually in rangeland landscapes, to help them with questions they have. So you would think that would be natural, but it's only been recently, I think, that the research stations have moved towards this kind of not really consulting format, but almost like that, consultant for the National Forest System. It got so bad, the relationship in the Forest Service got so strange that in 2015, there was a survey that went out. And this is important. A survey that went out, 27% of Forest Service respondents did not know, that's a National Forest System, did not know the Forest Service had a research branch. So recognizing this, some of us began pivoting towards working more closely with managers, and that's borne a lot of fruit. Some of that I'll share with you today. So keep that in mind as you think about your next step in your careers. All right. So when we talk about rangelands, it's everything in the yellow here. Yellow, and I should mention the afforested part in the purple areas. These are where the trees are getting in the way. That used to be non-forested. They would meet our definition of rangeland today, less than 25% tree cover historically, blah, blah, blah. All of the things that make a rangeland, but now have trees that are getting in the way, so they become afforested. That's about 662 million acres. And the Forest Service has a small portion of these rangelands. Let's say about 60% are non-federal. So the government doesn't really have, let's say, a management role there. But 40% are federal, so about 166 or 106 million hectares. BLM, let's see here. The BLM owns about 40 or manages about 47% of this. Forest Service, 17% is about 20 million hectares. Combined, these two agencies have about 64% of the nation's federally managed rangelands. And in 2011, when this map was made, the base was about 268 million hectares all in. 2017, we're down to about 266. Why? Because of continual development, continual agricultural expansion. We won't get into CRP, that muddies the water, but just recognize that there's a slow attrition rate on our nation's non-forest lands. So we consistently lose about 170,000 acres per year since 1982, but most of the losses occurred between 1982 and about 1995. So the rates of loss have slowed dramatically in our rangeland base, but we're still nibbling away, as you might imagine, at our rangeland base. So why are we talking about this today? There's a greater recognition because of all these issues. We have litigation, allotment management headaches, forest plan revision, always, National Environmental Policy Act, and then managing expectations and dealing with the fact we need way better communication. Trying to put people in a room on the same page is hard to do, but we don't do it very well. So we're trying to improve that. And one way you can do that is that we all have a common understanding of how many acres of this, how many acres of that, things we can agree on. Part of that comes from data and tools. So what kind of technologies are we going to cover today? Today, it's just loosely defined. It could be anything beyond a paper and a pencil. So you name it, it's out there, used in various contexts in the agency. And again, why the tools? Because of litigation. We're also faced with larger landscape questions. We're no longer just dealing with allotments and pastures. These are landscape scale questions. So we need landscape scale tools to get us answers. What about climate change? Yeah, that's a big one. And then finally, what if questions? So systems that can enable us to say, if we change our management in a certain way, what will the outcome look like? You could do that in a room like this and we can all talk about it. But with a common set of tools, we can all begin to get a sense of what a broad range of ecologists might expect. And the tools are scale dependent. And what I mean by that, today, mostly what I'm covering though is going to be remote sensing and modeling, so pretty large scale. Not only they scale dependent in space, but also time. And I like to develop 3 different time tranches where we look at tools. And those are what happened in the past. So tell us about past trends. What's happening right now? What's going to happen in the near future, say 4 months in the growing season, and then in the far future, like a climate change perspective. So we have tools that help us with each of these. And the Forest Service uses all 3, and increasingly so. This wasn't the case as much 10 years ago, let's say. One example of a tool, this is many millions of dollars of a system, the Vegetation GIS data system. It is a sampling protocol that it's a sampling device that enables you to put in all your common protocols that you're going to be using. Frequency, line point intercept, belt transects. These protocols are all built in here. It was developed at the University of Arizona. Forest Service has bought a lot of this, lock, stock, and barrel, pumped a lot of money into it. So VGIS is an excellent system if you're going to be doing a lot of ground pounding, a way for you to organize your data. So this is at the kind of plot scale you see represented by this here in this Sonoran Desert ecosystem. You'd use this at this kind of scale. There's been some talk of drones. One of the things that's interesting about drones here, we now have, I think, 27 drone pilots in the Forest Service, maybe 30, something like that. In either case, if you're a range manager in the Forest Service and you want drone overpasses, there's a number you can call and you get in the queue, and about 6 months later, y'all work together and then you begin the process. But it's now available. Here's an example of musk thistle. There's no sense in going into this into depth. Just recognize that increasingly drones are being used. There's still a lot of drawbacks here. Look at what you can see with a drone. In this case with musk thistle. They even attach herbicide to this now. And using AI, it can see the purple and be like, psh, squirt that piece. We're not there yet, but drones are being used. What about at a national forest scale? This happens all the time. This is a lot of what I do is at the national forest scale. This is an example of grazing suitability and capacity, where we take a look at the landscape and the distance from water. It's kind of like a holocheck model for your range management people. You take into account the slope, the type of critter we're evaluating, in this case, cows, and then distance from water. and you begin to model constraints on the landscape and barriers to move. So this is an example of a national forest scale, and this is taking like hotcakes. So we're doing an overhaul on a lot of the allotment management plans in the Forest Service, using these ideas to look at changes that have occurred over 40 years, because a lot of the allotment management plans were developed in the 80s and never revisited. A lot of change since the 80s. Well, this is one way we can get at it, is by doing this kind of work. We also work with permittees. So this is a permittee in northern Arizona, and we can look at the trend and the variability across all the ecological sites owned here, of course, with a lot of different tools, some of which we're going to go over in just a little bit. But you can look at trends over time, some cases from the 80s up to present day, you know, looking at the variability of the forage performance. So the interannual variability, the highs and the lows, but also the trend. Is it going up, down, or sideways? And in this case, this is variability. Warm tones tell us this is boring. This is where it's just flat. You can count on the forage year after year. Might be low, but you can count on it. The blue is where we see the greatest amount of variability, and they told us, yes, this is exactly in line with where the prairie dogs have come in. And because of that, the annuals have come in. So the variability is much larger. But working with permittees, we can begin to develop, help them think about, okay, no, just the present, don't worry. We can begin to think about some different kinds of grazing management plans that they might want to consider. So forage performance on a ranch scale, let's say. All right, let's go over a few tools here. I'm going to pull this out, and we can ask questions. Hopefully this will come up on the screen. I don't know if I have it in presentation mode, but it will. It's linked. Let's see. Does anyone know?
Your entire screen rather than just Microsoft.
Oh boy. Share?
Screen?
I'll let, yeah, you drive. I can't even spell it.
There you go.
Oh, okay, good. How did you do that?
So it popped up in Chrome, but
There's this really neat tool. It's called an internet browser.
share screen
So do we toggle back and forth then between the?
between this and your PowerPoint.
Okay, got it. So let's go over, this is going to take like 6 or 7 minutes or as long as we want it to. You can go to fuelcast.net. You can see the current Fuelcast, which is a projection system. It's a deployed artificial intelligence platform that based on precipitation that comes in daily, and then a weekly remote sensing data feed, and also a drought indicator. And it makes guesses as to what that might mean for forage in the near future. It looks out 4 months. So if we interpret this correctly, this is in California, you can't tell because I zoomed in too fast, but we're getting a lot of rain there, and we can't see the legend, but it's right here. I'll pull down this screen. You can see the percent change compared to the long-term average. So what it's telling us is these areas here are really 4 to 5x. Yeah, California's wet and it's been wet. And so we're going to see what the system is telling us is in these areas, the forage and fuels are going to be off the chart. The needle's all the way pegged to the right. So that's how we use this information, is to give people a heads up if we see things moving a long way to the right or a long way to the left in the forage and fuels domain. All right, so this, again, this tool looks forward 4 months from the beginning of the growing season. It looks out 4 months and makes a projection about the peak based on those indicators, the precip, the satellite imaging, and a drought indicator, and has a weekly ingest of these data. Let's look at another tool here. So that's just one. Oh, did anyone here attend the Rangeland Technology Summit from a couple of years ago? If you want to know about tools, forget about all this garbage here. One of the things we don't have is people to manage websites, but these are good. We can make tools, but we can't manage websites. I work for the government. We can't flush a toilet inside of a month. Look at the tools here. We got 43. These are little 5-minute snippets. This one, GrassCast. This one maps about invasive annual grasses. This one about automated capability assessment, so on and so forth. Here's one about land fire. So what these are is 5-minute snippets about 40 different tools, SPI Explorer, rangeland analysis platforms, blah, blah, blah. So this is a good spot if you want to learn about a tool. And for professors that have an interest in students knowing about tools, a good site to visit. So at the Technology Summit, we had like 43 speakers over 2 days, and we captured their tools with 5-minute snippets. There's also longer ones you can access if you want the deep dive. They're like 30 minutes. But using the 5-minute snippets, you can decide if you're interested in the tool or not. So, how about Art of Range podcast? Anyone go there? That surprises me. So Chip Hudson from Washington State University does this. Why is this technology? Because it's technology transfer, right? So this isn't necessarily a tool, but you can eat your sandwich. He's got over 100 episodes here. And he talks to some of the most famous people in the US, you know, at least in the range world, if you can call them famous. But browse all the episodes. So you go there, you click the thing, it's usually 40 minutes, and it's brilliant stuff. He does an interview and they talk about rangeland issues around the United States. So it's a great way to become informed about tools and ideas that are unfolding right now. So Art of Range podcast. This is one of my favorites, the Office of Climate and Sustainability Climate Gallery. This is from the Forest Service. Most people probably didn't even know the Forest Service had this branch. I didn't either until about a year ago. So if you didn't know about it, that's okay. But these are all apps you can use. My favorite here is the Climate Map Exporter. Let's take a quick peek here. This deals with climate change. And right now, just RCP 8.5 for those of you that speak that language. So let's say you just want to visualize some information. You want to make a quick map for a presentation. Let's choose Northern region. That's us here. And let's see, it's kind of thinking, let me turn off some of the other stuff. Go back here, where was I? Get back. All right, let's try it again. Climate map exporter, then it's just a series of maps about temperature, precip, snow residence time, snow water equivalent. Let's choose Northern and see what happens. Hello. It's hung. Look at that.
I think that's just a print screen. That's fine.
Well, you know, this is classic. All right. So I've used this tool 100 times. I know you're all going to laugh, but it's never done this. I swear. So what it does though, is it tells you, you choose the forest of interest and the variable of interest. You choose what you're after. I like percent change. You generate the map, and we'll take a look at a couple of maps because I have them in slides. That's a good tool, and there's a lot of information there if you want climate change graphics. How about the Geofencing Summit? I don't suppose anyone participated in this. Did anyone participate? Okay, so we had over 500 participants here from around the country, and I invited a lot of people from Montana and others to talk about their experience. But it's 2 days worth of information, everything you wanted to know about geofencing and how it's being employed. Right now, there are over 27 applications of geofencing in the National Forest System and the Bureau of Land Management, and it's going to grow rapidly. There's a lot of interest here around geofencing, and if you don't know anything about it, you might want to visit that summit. And I'll send out the links as needed. The reading the tea leaves here is something I do about once every month and a half. And I talk about what's happening around the West in terms of forage and fuels and what's emerging. Like, where's the needle starting to move? Where are we seeing problems or opportunities emerge? And part of that deals with the fuel casting effort, and we interpret those results. Most of them are 7 minutes or less. Most of the episodes are 7 minutes or less. So why is it a tool? Because it gives you an overview of, what's coming. It's kind of like a weather report, except for forage and fuels and what we think the near season, the near in season has in store for us. And one more. Oh, and I did the climate change adaptation library. No, I didn't do that yet. So I strongly encourage you to consider this if you're working with climate change. It's an adaptation library. It searches by keywords. This is the result of about 15 years work of work with managers. So we sit in a room like this and we talk through, when we talk about climate change, we think about the types of adaptation capabilities they have or that they would like. And those are captured in this library. So if you want options about adaptations for climate change, you're probably going to find something of use here, whether it's on sagebrush or cutthroat trout or sage grouse or whatever the key word is, you can search here. And that's another really good tool. So this is, again, the climate change adaptation library. Okay, so an overview, a few of the tools and moving on. Any questions before I move on? Thank God. Okay. Now to project work. So how are some examples of how we've begun to put this to work? So Clayton, you're going to like this. It's got the resilient word in there. I don't know what it means, but I put it in nearly every slide. So for the graduate students or even the undergraduate students, so site A or site B, which one do we think is more resilient?
A.
Does anyone know what this grass is? Damn it, I hate it when it's people guess the wrong way. But does anyone know what this grass is? It's cheatgrass, and it's pretty much there's some few stumps of some crested wheatgrass in there, but it's a bad picture, but it's all cheatgrass mostly. Versus this one, what you were supposed to say is, oh no, it's picture B because of the different life forms, right? So it's got biodiversity and all that stuff going on in there. So you're supposed to choose B, but why does it matter? It matters because of the soil organic carbon. And just real quick, if you look at these within the box, the perennial grass understory has a way higher percentage of soil organic carbon related to, and this is soil depth. So as we dig deeper, wow, look at that. The perennials are putting that carbon down deep where we want it. And this has significant implications for water storage, if nothing else. So we want that perennial grass understory. All other things being equal, you got to maintain the perennials. And that's going to set the stage for our project work here. Maintain the perennials. So how do we use tools to understand what's happening with the perennials? Well, this is the Kaibab National Forest here. There are 3 units. Grand Canyon is up here somewhere. No, it's right here. There's the Grand Canyon. And northern Arizona. This is looking at perennial forb and grass cover from 84 to 2020, 1984 to 2020. Red tones, and it's stratified by soils. In this case, terrestrial ecological units, which is the Forest Service correspondence of ecological sites. Forest Service always has to do everything differently. Differently. And these are just soil units. So what we do is we evaluate the trend of perennial forb and grass cover over time. Red is back. Look, this is a Pearson's correlation coefficient. If I'm red, that means I'm straight downhill with the perennials. That's not a good sign. We want to be in the blue category here. And this is one way we can begin to sort out the landscape and start asking why questions. But first, we need to define the battle space. What's going on? So this is just an example of perennials, where they're going up, down, or sideways. What about what is this one? Annuals. Those pesky annuals. Again, blue is an increase. Red is a decrease. They don't really have a significant annual grass problem here, so I don't want to focus on the slide. Trends can kind of fake us out a little bit, because if it's a significant trend, but it's only 3% cover of cheatgrass, we're probably not going to worry about it. So trend by itself, you got to take it with a grain of salt. But I just showed it for demonstration. What about trees and encroachment and stuff like that, which we'll get to in a second with some other tools? This is looking at tree cover. Again, the red tones mean they're going downhill. You're losing trees, but the blue tones, this is where you're gaining trees. And it may have been that there was no trees there before. So the blue, this is a fire here. So the trees are losing cover over time. The blue areas, these are especially the dark blue here, and especially here. This is I-40. Here's Flagstaff. You ever driven west on I-40, towards towards Kingman, Seligman, or Lake Mojave, any of that, you know there's a lot of encroachment going on out there. Well, you can make a map of it and then show people in the room, we can all get on the same page. That this is where the tree density problem's becoming an issue. And this is from the rangeland analysis platform. So we don't use the platform, we use the data associated with it, which is just a remote sensing evaluation of cover by life form from 1986 or 84 to present day, plus or minus, of trees, annuals, perennials, bare ground, etc. Any questions so far? Does anyone care? Yes.
Ask you a question, Matt, because I was on the north, I've been on the North Rim in those fires. So when we use the satellite data for tree cover, is there a seasonality to the measures that you make? Because the aspen, that burned all the ponderosa pine out, and the aspen really came in. So I could see a fall, winter satellite pass indicating very little tree cover. But a June, July satellite pass, lots of tree cover.
Mhm. Well, in this case, they use the whole stack of the year's worth of imagery, including precip and other predictors in there. It's gonna, using that full intra-year evaluation of the satellite overpasses, every 16 days plus or minus, it's actually more than that, but you can see both. And in this slide, because I just made it quick and easy, conifers are always way easier than deciduous, but it's going to catch the deciduous too. It doesn't just look one time or the other. It looks at every overpass and makes predictions according to that. So it would see those changes. For another project, this is central Utah, Monroe Mountain. They say, hey, we're gonna have 200 people in the room on both sides of the argument here. This is a very contentious area. They said, we need to understand what's happened over 40 years with the perennial forbs and grasses. I said, good, let's just pull up a quick map. So we have a series of grazing allotments here. Oh, doggone it. Let's see, right here. We have a series of grazing allotments. I think there are like 5. And again, these are the soil units. So we asked the question, what has the cover of the perennial forbs and grasses done at the soil units over time? And in this case, the yellow is bad. This is where they've been going downhill. And this, again, for Pearson's R, that's steep. That's this right here. This is time in years. And on the Y is the absolute cover of perennial grasses. And it's this trend was taken right here out of this circle in the yellow areas. So you don't want to see that because it's suggesting management changes maybe are needed. And what about litigation? And that's exactly what's happening. So having these tools helps everyone kind of get on the same page. We can agree if we both buy into this remote sensing stuff. It's another discussion. We can agree that we're kind of losing ground in these yellow areas, but other areas not doing too bad. So it's a nuanced question. And with these large landscape kind of tools, you can kind of sort it out, get everyone on the same page. That's why I like tools. It gets everyone on the same page. So this is Thunder Basin, another evaluation we've done, a resiliency checkup, we call it, just to take a look and see what is happening. Are we going up, down, or sideways? So this is Thunder Basin here, all the different, this is Wyoming, and this is Colorado. If we look at this area right here, it sticks out. The perennial cover, 86 to 21 in this case. Again, Pearson's R, we're yellow. No, we're going downhill again. And so you use this to help understand what kind of climate change implications we might be thinking about. Because if we're doing this now, what happens when we increase the prevalence of drought? I don't know, but this isn't going to help us. Remember that soil organic carbon slide I told you. And if we're doing this, that means we're losing carbon relative to our neighbors. That's a bad thing. And sure enough, that's this trend right here. This is an honest to God data pull. I didn't even mess with the points. So we look at the perennial forb and grass cover over time from that yellow area I showed you. And this is the canopy cover of the perennials here. Straight downhill. That's, who knows where we end. I mean, does it go to 0? I don't know, maybe. But this is where we've been. So being able to understand these trends and show everyone in the room where we're at is very helpful. Flip side, again, with trees. We are now Rocky Mountain National Park. We're in blue. Remember the blue shades were strong increases. And sure enough, out of this circle, we get this time series. The trees are going up, the perennials are going down. Now what? Not sure, but at least we've defined our battle space here with this kind of landscape level analysis and some freely available tools. Granted, I had to pull the data and make the maps myself, but big deal. Most of you could do that. Okay, so I told you, and then the tool didn't work, about the climate change mapper thing that got hung. Well, this is the output of that, and it usually takes like 5 seconds to draw. It's fast. So we were working with the National Forest, the Medicine Bow route, Colorado primarily, Region 2 we call it. A lot of the work we do involves climate change adaptation strategies. One of the things we do is look at exposure. Where is the rain expected to be less? Where is the snowfall expected to be less? Where are the temperatures expected to be higher or lower or whatever? In this case, what we're looking at, this is from that climate change mapper, this is snow residence time. And red colors mean we see one heck of a lot less snow on the ground over time than we would compared to our average over the last, say, 40 years. And in fact, so much so, it's saying these dark reds, that's like 100% loss. So by compare 1975 to 2005 versus 2071 to 2090, RCP 8.5, you don't need to get into the details. Just recognize it's telling us a heck of a lot less snow on the landscape compared to the long-term average. You show this to a room of people, you say, this is what the ensemble, the model average of projections looks like. What are we going to do about it? And that's when the discussion happens. So a lot of these tools are just to frame everyone's point of view. Now what? I don't know. That's up to the managers. But this is snow residence time. What about seasonality of precipitation? Again, the tool can help us understand. It's coming fall, spring, summer, winter. So interpreting this map, this is average winter precip percent change. Again, 75 to 05 compared to way into the future, the end of this century. It tells us that the winter precip is way more. Up here, we're seeing in this unit, we're already seeing, because of our checkup, we already deduced that the trees are going crazy. It's becoming encroached, right? The grasses are losing ground to the trees. I didn't show you that, but I'm just telling you, that's what's happening up here on this north unit. But what about, let's take a guess. So if we see greater precipitation in this otherwise, pretty grassy region, what does greater precipitation in the winter probably mean for life forms in the future? Do grasses favor this, or do shrubs and trees favor it a little more? Wintertime precip. On average, don't give me the exception. On average, the woody species favor this. And so let me get this straight. We're already seeing an overabundance of trees. And because of this anticipated change in wintertime precip, we're projecting an increase to the increase of the number of trees. So now what? Well, maybe we ought to be thinking about treating the trees now in preparation for becoming overrun with trees. I don't know if that will happen, but that's what this would suggest. And there's other models to let you pick away the layers of the onions to see, do we really think that this kind of precipitation in this region will lead to a greater abundance of trees and shrubs? So there's other models to help us figure this out. But on average, that's what we could expect, more trees. What do you do about it? So, talking about trees, I think we'll end over the next 10 to 15 minutes. We'll end with another project working again with Region 3. For some reason, the Forest Service up here seems like most of the research that they contact the station with tends to be with the carnivore research. Less so with the type of tools that I've shown you here. But the other regions of the Forest Service, Region 4, which is like, Utah, Southern Idaho, those places. Region 3, which is Arizona, New Mexico, part of Texas. Region 5, mostly California. They all engage with this kind of work every day. But up here, not so much. I don't know for sure why. But let's talk a little bit about the encroachment issue and some more tools to dig down a little deeper on this. So going back to the Kaibab, you ask, well, gosh, why is he working in the Kaibab? It's clear from Missoula. Follow the money. So even though federal researchers are funded, we're not, well, some of them are. Most of them are not soft money dependent, the way some professors would. So people say, well, why are you even looking for money in the first place? Well, because we can only do limited things by ourselves. So we need partners. And that's what we did here. So again, going back to the encroachment issue, we can see, you know, this was taken whenever it was, call it 100 years ago, not many trees, but boy, it's thick now. We all get it. We all know the story. There's too many trees. What to do about it? Well, we've got 4 tools here we're going to talk about. And tools can be data sets in a way. That's a tool. So this is a Region 3, very high quality data set. We probably look at $8 million to make these maps over 4 years with Oregon State. I wasn't involved, but anyway, it has polygons. And in each polygon, it estimates the species assemblages that occur there. Take it with a grain of salt, but at least it's mapped. So we use this information to identify where's our pinyon and juniper. But mostly juniper, less so pinyon. So you can choose and you can download. You choose the region you're interested in, you click it, and it gives you the database of all the polygons. These are large, like a couple of gigabytes. But they're just polygons you can view in your GIS, and they'll tell you what vegetation types you're dealing with. And it's going to be updated. This was 2017, but it's going to be updated again in 2024. So doing that, tell me where the pinyon and juniper is in the Kaibab National Forest. That's on green here. So about 37% of that landscape's now in pinyon and juniper. Had we gone back 100 years, it'd probably been closer to 10%. But we'll get there. We're not there yet. So we know where our pinyon and juniper is. Again, we're defining our battle space. Here's what it looks like. You got the polygons, and in each polygon, it defines the species and a whole bunch of other stuff. Some of it's not that useful. Basal area and some other stuff, foresters like, I don't know. But anyway, that's what you're looking at if you download this database. Pretty easy to use, just a geodatabase. What about tree cover? We want to understand where it's been going up over time. So again, we use the rangeland analysis platform. USGS has a competing product. It's called the Back in Time Vegetation Series. MRLC Back in Time, whatever that means. You can get the data there. We use this because it's a Google Earth Engine asset. So it's available through Google Earth Engine. You can grab it and manipulate it the way you want. Pretty easy. So we wanted to find out what the trends were looking like. And here we go. I showed you this before. This is a bit of an update, but the different polygons tell us, are the trees going up, down, or sideways? And look at the greens. This is where the gel is really moving on the plate. The eastern edge of this stuff right along I-40 and right over in here. So you can identify individual patches where the tree cover is going way up over time. Likewise, the red toms tell us where it's been going downhill over time. And this is what we're looking for. We want to identify where is that pinyon and juniper going like this? Again, time and cover. So map this against the pinyon and juniper. And we sit down, again, we sit down in a room like this. We talk about what we're looking at. What do people think about it? You know, it's a discussion support tool more than it is a decision support tool in that way. A lot of these tools are like that. Get everyone centered on the same page. So we've got soil polygons right here. Well, so there's trees there. Should they be there or not? I don't know. And that's what the local collaboration is for, is to help you tease that out. But once you come up with that matrix, then you begin to say, okay, we've shown you where they're getting thick. You've told us where they shouldn't be. We know where the pinyon and juniper are. Let's mash everything together to come up with a treatment plan. And that's where the LiDAR comes in. So the LiDAR is a way for, it's an instrument that allows us to understand the height of the vegetation. So we're dealing with pinyon and juniper. Are those tall species or short species? On average, relative to other trees. Well, some, you know, because you always get, well, it depends. Yeah, it depends, but on average, they're short. Thank you. On average, they're short. But this is a LiDAR map showing us those tree canopies. Why would we need, we already know where the trees are too thick. Think about being a manager. Why would we care how big they are? Right. If you're dealing with great big trees, that's much more expensive than dealing with the little tiny ones. So to make the biggest bang for your buck, you go after the small ones first, maybe. So whatever your budget is, you can help prioritize using tools to say, we're going to treat those stands there because it's pinyon and juniper. They'd be going uphill over time. We don't think they should be there. We have other management issues in those same polygons, and they're small. We can go get them with a hand crew or whatever. So that's why the height is very important. So you intersect all that information to come up with a battle space. And this is what you get on that southern unit. Color banana, these names don't mean anything. It's just a labeling I had for this slide. Bottom line is, these two colors are green. That one right there and this color are the targets because they're manageable size. They've been increasing way too much over time. Pinyon and juniper, and we don't think they should be there. There you got your treatment laid out right in front of you. This took 5 days to do this. So is it meaningful? Well, maybe, time will tell, but with the tools available, you can develop a map like this of encroachment very simply, provided you have the information to do it. So zooming in to along this road here, we see that dark color. It's telling us you're going to want to treat right along this soil type here. And it turns out there's a hilltop right here, and the soil breaks and it's a little different. And the trees, because they're facing up as north, so they're facing west, they've not been encroaching as fast because it's drier. So they say, you know what, let's treat this area first before we go here. So it's a way of prioritizing what we're going to do. And you see sort of the individual canopies here, although it's degraded, the LiDAR gives us that level of information. The rangeland analysis platform gave us the trend in the tree cover, and the INREV, or the polygons, told us what species we were dealing with. So lumping tools together and sitting down in a room with managers, this is very powerful, because then they sit there and they talk about it and they ask questions. And they say, well, what about the pinyon jay? We're about to get another lawsuit about that. What should we do about that? Well, I don't know. But that factors into what you're going to do. All we're providing is what the tool showed us, but it gets everybody talking and people on the same page. I think that's the most important thing. The tools will lie to us and give us bogus answers, but at least we're on the same page. So we can talk about it and figure out a solution. Maybe. 2 more tools before we go to lunch, I guess. So let's see here. Do I stop?
No, just need to be real quick.
Okay, come on. Come on. Oh, I hope it doesn't want me to sign in. Damn it. Okay, it does. So let me type in my email, and it's okay if you see it because it's on the screen and there's nothing I can do about it. So Climate Engine, in my opinion, and I do tools and stuff for my day job. Has anyone looked at Climate Engine? This is for any discipline dealing with just about anything that cares about rain or temperature or snow. I don't think, oh Lord. See, when I do this on my own computer, it already knows me and it doesn't have me go through this. Oh, you've got to be kidding me. But I want to show you a plan. All right, here we go. See if I can find my phone. Boy, I can't wait to retire. Not really. Climate Engine, again, a very multi-million-dollar platform. The University of Nevada, Reno, and others do it, but there is every kind of precipitation and snow and temperature and every kind of, yes, it's me, every kind of, tap the number, just 1 second, match the number. Oh, 54. Wow. Is it seriously asking me to do it again? Oh,
Yeah, like 1 minute.
Quit talking.
Yes, it's me. We'll get there. K-12, there we go. Boy, howdy. You gotta have, the only drawback is you either pay for this or you get, seriously, you either pay for it or you get a Google thingy. All right, so let's just take a look here. I am telling you, if you're gonna learn one tool, learn this one and learn it well. You have, look at the hydrology. You've got remote sensing, environment hazards, forecast. It's ridiculous, and it's on-demand cloud computing. This is the real deal, I'm telling you. And then these are the different data sets available. Really? Are you kidding me? Global and North American. And they just added SNODAS, which tells us where the snow is right now and how deep it is. Wow. I don't know, maybe I'm easily impressed, but so total, let's do percent difference from average over the last 60 days compared to the 81 to 2010. And you talk about getting people on the same page. It'll take it a little bit. Okay, there you go. So this is the precipitation difference. You want just a quick graphic for your class, for your meeting. Look at where it's been really wet compared to normal. Yeah, we know about the California thing. But yeah, look, I mean, this is very interesting, I guess. For me, it is. And you can go back in time. You can say, well, what about 05? How did that look compared to whatever, when we had that big fire year? And you can select the months you want and everything. I'm not going to go through it. But it's a pretty amazing tool to grab and visualize just very quickly the
Are the functions limited to just visualization, or can you?
No, you can
those
pull
data
it, you can graph it, you can make squiggly lines, bar charts, you can pull the data.
Kind of grab the raw data. that's
Yeah.
being plotted.
Yeah, you do, yes, you can make a graph, or you can, let's see here, which one is it? You select your box and you push the button and it's in here somewhere. We could go through it.
No, yes, it's fine. Thank you.
Yeah, it's there. Very helpful. So I use this a lot when we're, reading the tea leaves to decide, well, question for the students. So if I'm in a warm season dominated environment, shortgrass steppe right here. All right, so warm season, a lot of blue ground here. Is the precipitation I'm getting right now that meaningful for the yield of blue grama in August? Not as much. If this was a map in July or August and it was raining like this, Katie barred the door, it'd be knee high. But not in the spring. And you'll see that. So precipitation can trick you. Just because it's raining doesn't mean the grass is going to get green. And these maps can help you make that point. Okay, let me do one last little thing. Does anyone deal with soil moisture? Okay, this is soil moisture 327, so 3-day latency. This is the soil moisture anomaly, the crop chasma. Love this thing because it shows us where soils are wetter compared to long-term averages. Again, it helps us read the tea leaves and understand what we're getting into the growing season. So what if I'm in the Palouse country here? And by the way, the rangelands here are ground zero for cheatgrass, right? I mean, it's over. I mean, most of it, outside of a few areas, outside of a couple 100,000 acres here in Eastern Washington, it's going to be pretty tough to get out of this cheatgrass problem there. Right now, being dry is actually a good thing because it reduces the amount of cheatgrass. So I'd probably get run out of some places by saying that, but it is true. This is not a good picture for cheatgrass. And one other thing, you see this big brown red blob here? This has been persisting for like 2 years. Kansas, especially Western Kansas, has been getting wiped out. And you can tell just by the precipitation maps at different times, it never gets green there. And it never gets the blue color. So just by looking at the precip over time, you can tell, where the needle's been moving. So this is soil moisture. It's from a satellite. The overpass is once or twice a day. They aggregate the data every 3 days. So it's only been up since 2015, so the observations are limited, but it's pretty cool to have a soil moisture map. And you can change the time or do whatever you're going to want in there. And you can do a profile, like you can make a squiggly line by drilling down over time to look at the change in the soil moisture. All right. And I said there was one more tool, and you're probably tooled out. But these are my favorites, by the way. These are the tools that I really like to use to have dialogues with people. People will call and say, what is this year looking like? I'll say, I don't know. Let's take a look at a few of these tools. So this is PhenoMap. It looks at phenology. And let's look at percentile. I like percentile better. So we can tell where we're ahead or behind. And let's see, what the heck does it mean? Let's put a legend on there. Right here. Okay, so this peach color is the 25th percentile. So that means if you're peach, you're not growing at all. You're in the 25th percentile or less of growth for this period, this last week, over the last like 40 years. So it's brown, it's cold, nothing's happening. But if you're like in the green here, stuff's starting to move fast. And in fact, according to this, you're in the upper, so a lot of those moisture that's been headed this way is starting to finally have its impact in the Sonoran Desert is what this is telling us right there. So just by a quick glimpse, you can get a feel for your battle space, and you can zoom in, of course, and make whatever kinds of assumptions or graphics you need for the crowd you're talking to. Any questions about this? This is like a ton of tools, and I was surprised no one's used Climate Engine, just going to say. PhenoMap's a little more obscure, but all these tools can help us when we're having discussions with managers about what's happened in the past, what we think will happen in the near future, and what we think might happen in the long term. We've covered all three of those kinds of time crunches. Didn't go into so much the different spatial resolutions, but that's that. So we have tools at all scales. This is what we need to know. And the Forest Service is using them more than they ever have. We have the needs at all scales, both the spatial, like all the different tools we saw were all different spatial resolutions, from drones to plots to national stuff. And it's relatively new. So 5 years ago, not very much of this was possible. There's been huge changes in computational capacity in the last 5 to 10 years. I could not have made this presentation 5 years ago. So there's been a lot of changes. And the discussion support tool is a good idea. You frame the problem with a couple of the outputs of these tools, whether it's precip or the trend of trees, the trend of perennials, and then you just do something I'm not very good at, which is shut up and listen. And finally, as a student, I would encourage you to consider adopting one tool. Have it in, I've got this one tool I want to show you, that type of thing. So just pick one out of the whole universe and know it well. And when you're doing your presentations and your classwork, or you're doing an interview with whoever, and you can say, yeah, but we like to use PhenoMap because I think you'll go a long ways towards impressing whoever it is you're talking to just by mastering one of these basic tools. So fortunately for you, that's all I have.
So we have time for a couple of questions.
I'm just going to ask on soil moisture, crop cap, and what's the reservoir? There are 3 flavors. One is 9, one is 3 kilometer, and one is 1 kilometer. So it's relatively coarse, but you get a 3-day look. Yep.
You speak to, over the course of your career, how you've seen the changes in the acceptance or the skepticism of these tools, of these remotely sensitive data products. As you said that this is happening so quickly in the last 5 years. I mean, have you seen a rapid acceptance of the accuracy of these tools as well?
It depends. But I would say it's probably 30, 30, 30. 30 is lock, stock, and barrel, I'm all in. 30% is I'm not quite sure, and 30% is no way. But if I know who I'm going to talk to, and I can do a little background, I can understand where they're coming from, I can convert them pretty quickly. Because I'll say, well, if we're not going to use this, and we need to know across the Kaibab in 1 week what the trees have been doing. What's your strategy? That's a lot of driving. So,
You present the uncertainty of those tools,
well,
those three groups.
I'll be honest with you. The uncertainty question only comes up when we begin to have academic discussions. Managers want something. They want something, and they don't want to debate it. A lot of times they just say, help us out. What's been happening? The more you peel back the layers of the onion, you can get wrapped in this rabbit hole and you never accomplish what you set out to in the 3-day workshop that you had. But you could, if they said, we have to have uncertainty, then yes, you would do that. I usually just let them dictate where they want to go with it, knowing that we could if we had to. And it also depends on the tool. Like, how do you get uncertainty in the soil moisture? That'd be like a month. I don't know. So it's hard. A lot of times I like to couch the uncertainty in terms of variability rather than error in the instrument. Because boy, then what's the error of the instrument? If we look at the variability, the interannual variability and the spatial variability over, say, a grazing allotment, we can use that for the uncertainty. Because they can plan for things are low, they can plan for things are high. But it's hard to plan when you have no idea what to expect in the next growing season. That's a wimpy answer, but that's all I have.
All right. Thank you, Dr. Reeves, for your time.
Glad to do it.
Lunch with grad students now?
I wonder if we didn't have lunch here, how many people would have actually been here?